We would like to start off and welcome you all to this presentation made by me, Björn Widén, and my colleague Lukas Fogelberg. We're going to present a work done during a course at Luleå University of Technology regarding geotechnical calculations. Out in the industry, mostly amongst consultants, there are several different ways of handling a geotechnical calculation, and plenty of different computer softwares designed to make it easier for the constructor. We have decided to compare two softwares used in the industry, the Swedish software ScreenCast and the finite element program PLAXIS 2D and 3D. We have set up the same models in all of the three programs and used the same input parameters in all calculations. The results have then been compared with each other and with a real case supervised by Tyréns AB in Sundsvall. Some brief information about the case in Nacksta, Sundsvall. A slope stability improvement is needed during a soil remediation project with the objective to remove large soil masses where oil has leaked out. The location of the leakage is just nearby the northbound railroad tracks out from Sundsvall, Sweden. To be able to perform a safe excavation, maintain the stability of the railroad track and at the same time eliminate the risk of displacement, a sheet pile wall has to be installed. The Swedish computer software ScreenCast is designed to make sheet pile wall calculations faster. The software is using the same type of calculations as when you hand calculate earth pressures along a sheet pile wall in a 2D case, and the output from the program can give you the design value of the bending moment for the sheet pile wall. ScreenCast is to be used as a first-hand calculation and suitable for sheet pile walls that are stretching for a long distance. Since the computer software do not give output regarding movements in the wall or in the surrounding soil, this software should be complemented with additional calculations regarding movement. These kinds of calculations are of interest when constructing and excavating nearby buildings and constructions that are not meant to settle or have any additional movement. ScreenCast is also missing the ability of putting a pre-stress on the anchors, which is of interest when excavation is done in several steps with tiebacks on different levels.
Shortly about PLAXIS 2D and 3D. The computational software used in this study is PLAXIS 2D and PLAXIS 3D. PLAXIS is a finite elements method, which is a numerical method used to find approximate solutions to partial differential equations. From a geotechnical point of view, the simulation in PLAXIS is used to model stresses, displacements and pore water pressures.
The output showed that ScreenCast gave a higher value in bending moment in comparison with PLAXIS 2D and 3D. In relation with the results that Lukas is going to present in a while, the results from ScreenCast can be seen as on the safe side, and the design of the sheet pile wall may be over-dimensioned when using ScreenCast. Again, ScreenCast cannot give any output regarding displacements, which is of high interest in this kind of project.
Regarding the displacement of the sheet pile wall, it has been seen from field measurements that the largest movements have occurred in approximately the upper middle part of the sheet pile wall and show a value of 15 mm. This corresponds well to the results gained from the PLAXIS 3D software, but not for PLAXIS 2D. From PLAXIS 2D and PLAXIS 3D, it was shown that the highest displacements were also occurring on the upper middle part of the mid-sheet pile wall, where the largest displacements are measured to 45 mm in PLAXIS 2D and 13 mm in PLAXIS 3D. The displacement in PLAXIS 2D are in general overestimated due to modeling in plane strain, and when comparing to the field measurements, the results from PLAXIS 2D were exceeding by approximately 200%. Regarding PLAXIS 3D, there were more similar results as gained from the field measurements, although it falls short of approximately 13%.
To summarize, ScreenCast is to be used in elongated constructions, and the results should be seen as a first-hand calculation. ScreenCast is also lacking of ability to generate displacement and the actual behavior of the soil. PLAXIS 2D is, as sponprogrammet, suitable for long constructions, that is, when modeling with plane strain situations.
For this specific case, PLAXIS 3D is most suitable since the sheet pile wall is only 40 meters long. The results can then be affected by the surrounding geometry and constructions. This is neglected in both sponprogrammet and PLAXIS 2D. Thanks for listening. If you want to know more about this project and our calculations, you are welcome to read our conference articles. Thank you.